Hello and welcome. Today, we're going to talk about a small but incredibly important part of modern electronics, the operational amplifier, or Opamp for short. You might not realize it, but Opamps are everywhere. They're in your phone, your car, medical devices, and even robots. These tiny components help make our technology smarter, faster, and more precise. In this video, we'll explain what an Opamp is, how it's made, how it works, and why it's so useful in real life. By the end, you'll see why this little device is such a big deal. Let's get started. So, what exactly is an Opamp? Think of it as a super smart helper that can take two electrical signals, compare them, and then make the difference between them bigger. It has three main parts. One input called the inverting input, marked with a minus sign, another called the non-inverting input, marked with a plus sign, and an output where the result comes out. Opamps are like math wizards for electricity. They can add, subtract, multiply, and even do more complex things like integrate or differentiate signals. Engineers love them because they're small, easy to use, and can be adapted for many different tasks. Whether you're building something simple like a filter or something advanced like a robot, Opamps are often the go-to tool. Now, let's talk about how these amazing little devices are made. Modern Opamps are built using a material called silicon, which is also used to make computer chips. Inside the Opamp, there are tiny parts like transistors, resistors, and capacitors that work together to process signals. In the past, Opamps were made using vacuum tubes, which were big and used a lot of energy. But thanks to new technology, today's Opamps are much smaller and more efficient. They're made using a process called photolithography, where microscopic patterns are etched onto silicon wafers. After they're made, each Opamp is tested to make sure it works perfectly. This process shows just how advanced modern electronics have become. Let's break down how an Opamp actually works. It takes two input signals, one from the inverting input and one from the non-inverting input, and compares them. If the signal comes from the inverting input, the output flips it upside down. If it comes from the non-inverting input, the output stays the same. The amount the signal gets bigger depends on something called gain. Gain is like a volume knob for the Opamp. It controls how much the signal is amplified. Engineers can adjust the gain by adding resistors to the circuit. For example, in one setup, the gain is determined by the ratio of two resistors. This flexibility is one of the reasons Opamps are so widely used. Now let's talk about where Opamps are used in real life. The answer is simple: everywhere. In audio equipment, Opamps help make sound clearer and louder without distortion. If you've ever enjoyed music through headphones or speakers, you've probably benefited from an Opamp. In the medical field, Opamps are lifesavers. Devices like ECG machines use Opamps to clean up tiny signals from the heart and make them easier for doctors to read. They're also used in ultrasound machines, pacemakers, and blood pressure monitors. Without Opamps, modern medicine wouldn't be nearly as advanced. In robotics and mechatronics, Opamps are just as important. They help control motors, process data from sensors, and ensure precise movements. Factories use Opamps in machines that build cars or assemble products. Even drones and self-driving cars rely on Opamps to stay balanced and move smoothly. And that's not all. Opamps are found in everyday gadgets like smartphones, TVs, and gaming consoles. They help regulate voltage in power supplies and chargers, making sure your devices work safely and efficiently. Scientists also use Opamps in tools like oscilloscopes to measure and study electrical signals with great accuracy. To sum it up, Opamps may be small, but their impact is huge. They're used in everything from audio systems and medical devices to robots and consumer electronics. Their ability to amplify, filter, and process signals makes them essential for modern technology. Understanding how Opamps work helps us appreciate the incredible engineering behind the devices we use every day. We hope you enjoyed this video and learned something new. Let us know what you think in the comments. What other cool technologies should we talk about next? Don't forget to give this video a thumbs up if you found it helpful. Subscribe to the channel for more content like this, and activate the notification bell so you never miss an update. Thanks for watching, and we'll see you in the next one.